Okay, so today we're going to talk about acids and bases. Okay, so you should be very familiar with this. However, we are going to recall the definitions of acids and bases and how to distinguish one from the other. Okay, so in defining acids and bases, a lot of scientists have their own definition. For example, we have here Arrhenius's definition. Okay, so Arrhenius is a chemist, and he defined acids and bases based on the following criteria. So, according to Arrhenius, acids are the substances that, when you dissolve it in water, the concentration of H3O or hydronium ion increases. That means, for example, I have hydrochloric acid. If it dissociates into H plus, since this molecule will produce H plus upon dissociation, we can call this molecule an Arrhenius acid. Okay, so for bases, on the other hand, Arrhenius defined bases as substances in which the concentration of hydroxide increases when it dissociates. For example, we have sodium hydroxide. When sodium hydroxide dissociates, it produces sodium ions and hydroxide ions. Since sodium hydroxide is able to produce hydroxide ion, that means sodium hydroxide is a base. Okay, so that's the fundamental idea. So for Arrhenius, if your molecule produces H plus, that molecule is called an acid. If it produces OH or hydroxide, it is a base. Okay? By the way, for the rest of the topic, we're going to call hydronium ions as proton instead. Okay? So here's for example, you can see hydrogen dissociates into H plus. So since it produces H plus, that is an Arrhenius acid. On the other hand, sodium hydroxide produces hydroxide ions. That means it is an Arrhenius base. Okay, so for acid, it produces protons or H plus or H3O plus, whatever you want. And for bases, it produces OH. However, Arrhenius's definition is quite limiting because later on, as chemistry progresses further, they found out that Arrhenius definition for acids and bases is quite limited only for those substances who produce H plus and OH minus. Okay, what if they do not produce H plus and OH minus? So, that's a concern for the chemists before. So they defined new definition for acids and bases. Okay, so with that, two chemists, Bronsted and Lowry, redefined the definition of acids and bases. Okay, so instead of producing just protons and hydroxides, Bronsted and Lowry made the definition more broader, wherein if you have an acid, it will generally produce protons, still H plus, similar with Arrhenius acid. But this time the term is proton donor for acids. However, for bases, these are molecules that accept proton. Okay, so instead of talking about hydroxide for an Arrhenius base, for Brnsted-Lowry base, that is the molecule that accepts the proton that came from acids. Okay, so that means this definition is much broader because it can define which molecules are acids and bases for a huge variety of chemical equations. Okay, so for example, we have here um, we have hydrochloric acid dissolved in water producing hydronium ion and chlorine ion. Okay, so as you can see, um, the hydrogen of HCl is transferred to H2O, giving it an additional number of hydrogens. Okay, so that means since HCl donated a proton to water, that means HCl is a Brnsted-Lowry acid. Since this water molecule accepted the hydrogen from the acid, that means this is a Brnsted-Lowry base. So that's the idea. Okay, so moving to the next problem, we have here hydrochloric acid reacted with ammonia, producing ammonium chloride. As you can see, the hydrogen of hydrochloric acid is transferred to ammonia. Okay, so we have here NH4. So that means HCl is still Brnsted acid, and ammonia, since it accepted the hydrogen from this acid, it is a Brnsted-Lowry base. Okay, so let's talk about conjugate acids and bases, because you can see for acid-base reaction, the proton is being transferred from one molecule to the other. Okay, and the difference in the number of hydrogen of both molecules vary by a factor of 1. For example, we have 2 hydrogens here. In this part, we have 3 hydrogens here. We have 1 hydrogen here. In this part, we don't have hydrogens here. Okay, so those pair of molecules that has decreased in number of hydrogen or increase in number of hydrogen atoms, we call them the conjugate acids and bases. Okay, so when you say conjugate acids and bases, these are molecules that are related to each other by the gain or loss of one hydronium ion. For example, we have here acetic acid reacting with methylamine. So what happens is that this hydrogen is being transferred to ammonia, the amine part here in the next molecule. Okay, so as we can see, acetic acid loses 1 hydrogen and methylamine gains 1 hydrogen. Okay, so since acetic acid lost 1 hydrogen, we call this the Brnsted-Lowry acid, or just basically acid, and we call methylamine the base. Okay, so the molecules on the product side are derivatives of the reactant molecules. Okay, so that means this acetate ion came from acetic acid. Okay, so since acetic acid is an acid, acetate ion is what we call the conjugate base. Okay, conjugate base are the counterpart for the acid molecule. Okay, so the counterpart for acid is the conjugate base. So that means also the counterpart molecule for base is the conjugate acid. Okay, so that means if methylamine is the base, methyl ammonium ion here is the conjugate acid. Okay, this pair of molecules is called the conjugate acid base pairs. Okay, the pair of acid and the conjugate base is one conjugate acid base pair. The pair of molecules the pair of base molecules and the conjugate acid molecule, we call them another conjugate acid base pair. Okay, So let's have another example. So we have here, the two equations are the same. This is just the molecular representation of this reaction. So you can see here, we have here acetic acid. This is water. This is acetate. And this is hydronium ion. Okay, so as we can see here, the acetic acid and acetate ion here are related. Okay, since the acetic acid lost one hydrogen in the product side, that means acetic acid is an acid and acetate ion is a conjugate base. Since water here increased in number of hydrogens, we have 2 hydrogens here. On the product side, we have 3 hydrogens here. We call this pair, we call water here the base, and the hydronium ion as the conjugate acid. Okay, so that's the idea. Conjugate acid-base pairs are molecules which are related from each other. The only difference is that one molecule has greater or lower number of hydrogen. Okay, so you have to remember this, by the way. You have to remember this pairing system. Okay, so this is acid conjugate base pair. This is base conjugate acid pair. So that's the conjugate acid base pairs we have here. Okay, so let's have another example. We have ammonia reacting with water to produce ammonium ion and hydroxide ion. As you can see, ammonia and ammonium ion are related molecules. Water and hydroxides are related molecules. As you can see, hydrogen from water is being transferred to ammonia. Okay, because H2O in the reactant side became OH only. Okay, so that means water lost its hydrogen to ammonia. Okay, so since water donated a proton, this is our acid. Ammonia accepted that proton, that means ammonia is a base. That means ammonium ion here on the product side is called the conjugate acid. Sorry for that, that's acid. Okay, so the ammonium ion is a conjugate acid. Hydroxide here is the conjugate base. Okay, so the tip here is that pair two molecules that are related from each other. Identify first which one is the acid or base. The definition should be the Brønsted-Lowry definition. Okay, and after identifying which one is the acid, which one is the base, the molecule related to the acid on the product side is called the conjugate base. The molecule on the product side that is related to the base, we call that the conjugate acid. So that's all.